Here are the three rules of significant figures. As we have mentioned in class, significant figures are important for scientists because it helps us to determine what to round to, and it's always based on the information that's provided in a problem, which I'll show you on the next slide. But for now, we're just going to focus on the three rules that significant figures, when we are trying to identify significant figures, we use. The first of which is that zeros within a number are always significant. So what this would look like is if you had a number of 2001 perhaps, though these two zeros are within numbers that are going to always be significant. The 2 and the 1, those values are always significant. SIG, I know it looks like a 2-year-old wrote that, but it's the best I can do. So SIG, significant, 2 and 1, those are both significant numbers. The zeros are in between them, and thus they are always going to be significant. It would be true as well if you had a decimal, if you had 0.1001 perhaps. These ones are both significant, and that makes all of the zeros significant that would be between there. There could be 10, 20, 30, they'd always be significant. Second rule, zeros that do nothing but hold the decimal are not significant. So zeros that hold the decimal would be a number like 250, for instance. This 0 at the end of 250 is nothing more than a placeholder for that decimal. It's just saying that you have extended the decimal out one more position into the hundreds. It would be true if you had a decimal as well, that these zeros are not significant because they're nothing more than holding a decimal place. It wouldn't matter if you had 250 million and you just had 6 zeros after, 7 zeros after, whatever it may be, or if you were to extend the decimal place out for 10 positions. It wouldn't matter. Every zero would be insignificant if there is no number other than 0 after them, or in the case of the decimal, before the decimal. The last point, trailing zeros that are not needed to hold the decimal point are significant. So what this is referring to is if you had a number that had a decimal in it and then zeros after, what that number would look like to us would be something like 3.00 perhaps. These zeros are These zeros are not needed to hold the decimal point because the decimal point has already been placed here. Oh, sorry guys. Learning this program. So the decimal point has already been placed between the 3 and 0. Thus, it's not needed to hold the decimal point any longer, so that makes every digit that comes after that decimal place 0 as long as there was a number other than 0 preceding it. The same, well, I don't think it would be the same if we began with a decimal place. Those are the three rules of significant figures. Kind of the general rule of thumb is that if you're not sure whether a digit is significant or not, just assume that it isn't. And typically, you would be correct. So now that we have learned the rules again, or reviewed the rules again, let's learn how we apply these significant figures to a problem. So in the future, you will be expected to do everything in the correct number of significant figures in this class, whether it be something we're talking about in chemistry or we're talking about in physics. But something you may not have known is even in math, you would have to use the significant figure rules. And so typically in math, you'll see something like maybe a rectangle. Let's calculate the area of a rectangle. That's pretty easy to do. Let's say that the rectangle up top had 2.75 centimeters. And then down the side it was 1.5. So we know that the answer, centimeters, is going to be 2.75 centimeters times 1.5 centimeters. And so we take out our calculator really quickly and we punch in 2.75 times 1.5. And our answer is 4.125 square centimeters. But we may or may not be in the correct number of significant figures, so we need to check our our problem. Our problem said that we had a length of 2.75 and a width of 1.5. And so from the problem, we have to choose the fewest number of significant figures involving the numbers in the question. And so the numbers involved in the question were 2.75 and 1.5 centimeters. So which one of those would have the fewest number of significant figures? 2.75 would have 3, 1.5 would have 2, which tells us that our answer should have only 2 significant figures. So we look at our answer, and the first 2 significant figures are the 4 and the 1. So what we do with this is a couple of things. One, I want you to always look at the number that's after the last significant figure. So in this case, 1 is our last significant figure, so look at the 2. If the 2 was a 5, a 6, 7, a 9, you could round the 1 up, and that's what would be expected of you. Since you cannot, you would just round this answer down, and it would be 4.1 centimeters squared. And this would be our correct answer with proper significant figures. Let's check another one of these. Let's do an area of a triangle. So if we had a triangle, and our triangle had a base of, I don't know, let's do 5.45 centimeters. And our height had a distance of, this is going to be hard to do. Let's say that the height of the triangle was 6.7520. So we need to figure out how many significant figures there are in both of our numbers. And then we also need to know the area of a triangle formula. So, oops, got my units. So centimeters. So the formula, area of a triangle is 1/2 base times height. I think you're all aware of that, hopefully. So the base of our triangle is 5.45 centimeters, and our height is 6.7520 centimeters. Oof, barely made it. So what I would like for you to do is take out the calculator, punch these values in. So 5.45 times 6.7520, and that gives you 36.7984 divided by 2, so we can take off half, and you would get an answer. Your area is equal to 18.3992. However, our answer should have only 3 significant figures because 5.45 has 3 significant figures, 6.7520 has 5 significant figures, and it has 5 because that 0 came after a decimal, and thus it is significant. I hope you can see the decimal. If I do this, it usually freaks out on me. Our area was 18.3992. And so with proper significant figures, our first 3 significant figures are 1, 8, and 3. So after the 3, I want you to look at the next significant number, which would have been a 9, and I want you to, the next number, which was a 9, it's not significant, and I want you to round it. I want you to use it to round the 3 up. And so the area of this triangle should be 18.4 centimeters. And that's it. So hopefully, in addition to class, this has helped supplement what we discussed, and maybe you have a clearer view of significant figures. At least that's my hope anyway.